Hello everyone. Today we are going to explain what are the main uses of a multimeter. We have already explained what is a multimeter. A multimeter is an instrument or it is a digital multimeter. A digital multimeter can be used as an ammeter, voltmeter and ohmmeter. That means it can measure voltage, it can measure current and it can measure resistance. Sometimes it is also known as VOM, that is volt ohm meter. Right? Now let us check what are the various uses of this multimeter. How can we use it in our daily life? I already told you that in this digital multimeter there are many factors which you can measure. Here you see there are two signs. This is the measurement for AC voltage. This is the measurement for DC voltage, right? And this is for current. This is for DC current, right? That is 2000 microampere to 200 milliampere, and this is 10 ampere. And here you see this is the continuity test. You see here this is the continuity test, and this is the square wave, and this is HFE. That means we can measure the beta of a transistor. Here you see there are given two types of transistor, PNP transistors and NPN transistor. We'll show you how to measure what are the different uses of these digital multimeters. First of all, we'll try to measure the voltage, right? How we can measure or how we can connect such that we can measure the voltage. Remember that a voltmeter is always used as parallel connection, right? That means by parallel connection we can measure the voltage. Now see how we can measure the different types of batteries. I will show you, and you can measure the voltage of these batteries, potential or voltage. You see here this one. These are the different types of batteries you can see here, and we will connect all of them in parallel so that we can measure the voltage of these different types of batteries. Let us see how we can measure the different types of voltage and what is the measurement of it. Now I have already discussed that this is the positive probe. The red one is a positive probe and the black one is the negative probe. This is a positive and this is negative probe. Red one is a positive probe and black one is a negative probe. Now you see how to measure. You see this is our arrow. You see this is our arrow. That means we are measuring DC voltage, right? Therefore you have to put this arrow in the 20 volt section. This is 20 volt. This here, this is 20 volt. You have to put this in the 20 volt section, and now we will measure the voltage of the different batteries. Let's see what is the reading now. Just see what we will do. This is the positive, this is negative, right? Now you see here in the batteries here there are two signs given. Here you see that this is the positive terminal and this is the negative terminal as it is indicated here. Now we will measure the voltage of this battery, right? Let us measure. You can see here that it is given that it is 9 volt battery for transistor radios, right? Now we can measure with this voltage with the help of this digital multimeter. Now see, this is the positive probe. That means we have to take this positive on the touch this on the positive terminal. You see, we are touching it on positive terminal, right? See here, that is positive terminal, right? Positive terminal. And this one on the negative terminal, right? This one on the negative terminal. Now you see the reading is 9.65. That means this is 9.65 volt, right? It is very easy to measure because the positive terminal should be touched with the positive terminal of the battery, and the negative probe should be connected with the negative terminal of the battery. Only then you can measure the potential or voltage of this battery, that it is 9.65 volt, right? You can see here it is 9.65. See this one, the 9.65 volt, right? In this way we can measure all the batteries, but remember that you have to measure it in parallel connection, because in parallel connection we use the voltmeter. In the same way we have to use the digital multimeter in parallel connection. That means in this way you have to measure. This is the positive terminal, right? And this is the negative terminal. You see here the reading is 9.57 volt. Therefore the potential or voltage of this battery is 9.57 volt. This is 9.57 volt. We have all other batteries also. Let us check what is their voltage. You see here in this battery, this cell, we can say it as a cell, and when two cells are joined, then it can be said as battery. It is a cell only, right? Now you see in this cell, this is the positive terminal and this is the negative terminal, right? Let us put this positive probe on the positive terminal and negative on the negative terminal, and let's see what happens. You see here, let's see what happens. Here you see, that is, it is 1 point, nearly it is 1.31 volt, right? That means the voltage of this cell is 1.31 volt. It is 1.31 volt. But you have to remember that you have to measure the voltage by parallel connection, right? As here, this is the positive terminal and this is the negative terminal. This is the negative terminal, and you can measure the voltage with the help of this digital multimeter. Here it is also near about 1.17 volt. Therefore the potential or voltage of this cell is 1.17 volt. Now you see there are four batteries, batteries. You see here, these are button batteries, and in button batteries also you can see the positive and negative terminal. You see here, this is the positive terminal. You see here in a better way, you can focus it. Let's focus. Right, this is the positive terminal and this is the negative terminal. Now you have to measure the voltage of this cell. Let us button cell. Let us take this positive terminal on the positive side and negative probe on the negative side, and we measure the voltage. Yes, here you can see that the voltage is 1.36 volt. Therefore you can say that the voltage of this button cell is 1.36 volt, right? This is 1.36 volt. We have another cell, button cell. This is the positive side and this is the negative side. This is positive and this is negative. Let's check what is the volt of this cell. It is 1.35 volt. You can see here it is 1.35 volt, right? That means you can measure in this way. Here let us measure the same another, that is another cell. It is 1.33 volt. You see here it is 1.33 volt, right? And let us check this one also. This is positive, this is negative, and this one is also 1.34 volt. The voltage of this cell, button cell, is 1.34 volt. That means you can measure the various batteries with the help of these digital multimeters, or you can measure the voltage of different types of batteries. Right now, here you can see this is a battery or two cells, and they are connected. How they are connected, you see here. If you see clearly that this one, see this one, that this is the positive terminal and this one is the negative terminal, right? And here in this cell also you can see it in a better way, that this is the positive terminal and this is the negative terminal. Now how we are using this one, right? You see here that you will see very clearly that this is the positive side. You see here it is given that this is the positive side, this one, and this is the negative side. That means we have to put this battery in this way. This is negative and this is positive, right? And you can see it very clearly, right, that this positive is connected with the negative. This one positive is connected with negative. That means they are connected in series, right? If the positive is connected with the negative, that means it is connected in series. Let's see what happens when we put two batteries in a series connection. See, this is series connection. You see this positive is connected with the negative, right? That means this one is positive, this one is negative, this one is positive, this one is negative. This red one is positive and the black one is the negative. Now let's see how we can measure the two cells of this arrangement, or they are connected in series. Let us check. You see this is our positive terminal, and then connect it with the positive terminal of this battery. You see here, and this is the negative terminal, connected with the negative terminal of the cell, right? What's the reading? You can see it very clearly. It is 2.92 volt, right? 2.92 volt. I already discussed or already found out that in one cell it is nearly 1.5 volt. Therefore, it is the voltage is added in series connection, right? The voltage is added in series connection, right? If we can add the, that means this one, you see, we can check in another way. This we got, this is the 2 voltage as 9 volt, right? If we connect these batteries in series connection, then we will measure that the voltage will increase, right? The voltage will be added. We already found that these are of 9 batteries, 9 volt battery. See here, it is 9 volt battery. You can see here that it is 9 volt. Yes, you can see it, that it is 9 volt battery, right? Now it is 9 volt and it is 9 volt. If we connect these two cell in series, then how we are getting, then we will measure the voltage of these two cells if they are connected in series. Now you see very clearly that this is positive one, this is positive, this one is positive, and this one is negative, right? Now you see here. Now if we connect this positive with the negative, then it will be connected in series. Let us connect this with a wire. You see here, we connected this with the help of wire. This is negative and this is positive, right? That means they are connected in series. And let us check how much voltage we are getting. You see, this is the positive probe and this is the negative probe, right? And if we touch this positive probe with that of negative probe, and we'll find the voltage. You see here, it is added 9 volt plus 9 point something volt and 9 plus something volt, we are getting 19.21 volt. You see here, 19.21 volt. That means these are added, right? We already found that it is 9 point something and it is also 9 point something. Therefore, added to get it. That is, if they are connected in series, we are getting how much? It is 19.20 volt. And the question, what happened if we arrange them in parallel connection? You see, series connection means positive terminal is connected with the negative terminal and the voltage is added, right? Now what happens if we connect these two cells in parallel connection? What is the parallel? First we have to know that what is the parallel connection. Parallel connection means that positive terminal should be connected with the positive terminal and negative terminal should be connected with the negative terminal, right? Let us check. Here is C, right? That is, we'll connect the positive terminal with the positive and negative terminal with the negative terminal. You see, this is positive and this is also positive, right? And if we connect with another wire, positive with positive and negative with negative and negative terminal with negative terminal, then what we get, you see here, we are connecting this with the positive terminal with the positive terminal and negative terminal with the negative terminal. You see here we are connecting this one, that is negative terminal with the negative terminal, right? We can see. Now what happens, we see here, right? If we, then we have to take two more wires to measure this one. Now you see here, let us check that this is our positive terminal and this is our negative terminal. This is positive and this is negative. You see here, if they are connected in parallel connection, we are getting the voltage as 9.61 volt. There is the voltage is same, right? The voltage is same. You see here, the voltage is 9.61 volt, right? That means if the cells are connected in parallel, then the voltage is same. Since this is 9 volt, this is 9 volt, the voltage is the same, that is 9 volt in parallel connection. If we connect it with this in series connection, then it will be, the voltage will be added. That is our conclusion, right? In this way, we can measure the various voltage with the help of these digital multimeters, and we can check the voltage of the different cells or batteries, right, with the help of digital multimeter. This is one of the use. I already told you that we can measure the voltage, we can measure the current, we can measure the resistance, we can check continuity, we can check the square wave, we can find the beta value, that is HFE of a transistor. In this way, we have various uses of this digital multimeter. That's why we call it as multimeter. That means this meter can measure voltage, can measure current, this meter can measure the resistance, it can also check the continuity of any components, electrical components. Dear friends, today we have already discussed only this one, that is about voltage, how to measure voltage and how we can increase voltage. By series connection, we can increase the voltage of batteries, and by parallel connection, we can get the voltage same as that in this way. If we connect the negative with the negative terminal, positive with the positive terminal, then this is this parallel connection and we're getting the same voltage, that is 9 volt, right? In this way, whatever we need, we can mix series connection and parallel connection to get the desired voltage, right? Whatever we want, that we can mix it with series connection and parallel connection and we get the desired voltage as we wish. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.